Hello friends. Welcome to Dr. Rajendran's online academy.
Dear Professor, could you please explain the latent heat by solving a problem?
Sure, here we go. For this purpose, let's consider the enthalpy of fusion, also called the latent heat of fusion. To heat 1 kilogram of water from 283.15 Kelvin to 303.15 Kelvin, that is from 10 degrees Celsius to 30 degrees Celsius, requires 83.6 kilojoule of heat energy. However, to melt ice and raise the resulting water temperature by 20 Kelvin requires extra energy.
Extra energy? Really? But, in both the cases, the change in temperature, delta T, is 20 degrees Celsius, or 20 Kelvin. Then where does this extra energy comes from, in case of ice?
At first, let's calculate the total amount of heat required to raise the ice temperature as mentioned. Whenever a phase transition takes place, we need to mine the latent, that is, the hidden heat of phase transition. So, the amount of heat energy required for the ice melting can be split into two different heat values, that is, the latent heat, and also actual heat required to cause temperature change. The latent heat of fusion of ice is equal to 333.55 kJ per kilogram. In addition, the heat required to cause the temperature change can be calculated from the specific heat equation. Heat Q is equal to m multiplied by C's multiplied by delta T, where the mass m is equal to 1 kilogram. The specific heat of water is equal to 4.184 joule per gram per Kelvin. Therefore, the heat is calculated to be 83.6 kilojoule. The total energy is equal to the latent heat plus the actual heat, which is equal to 417.15 kilojoule. From this calculation, it can be understood that 1 kilogram of liquid water takes 83.6 kilojoule of heat to warm by 20 degrees Celsius. However, to cause the same temperature change, 1 kilogram of solid ice takes 417.15 kilojoule. The extra energy of 333.55 kilojoule per kilogram is called the latent or hidden heat. Such a hidden heat can be found whenever there is a phase change.
Wow. That's great to learn. Thank you, Professor.
Alright. That's all for today's class. See you in the next class.